6.3 is called Solving Systems by Elimination. Before we actually talk about elimination, we're going to actually go with what we talked with opposites. If I gave you -2, you would recognize that 2 is its opposite, and -2 plus 2 adds up to 0. Or -5x, its opposite would then be 5x, so -5x plus 5x equals 0. What my goal is today with elimination is to add things together that add up to 0. We're dealing with opposites. So our goal is to eliminate a variable. This is similar to substitution, but it's a little bit easier, I think, and it always works. You're never going to find a system where this won't work out nice for you. So let's actually do an example first, and then we'll talk you through it. we'll give you some steps, like ABC kind of steps. X minus 2y is equal to 19, and 5x plus 2y equals 1. What I want you guys to notice here is in this column right here, I actually have opposites. If I were to add these two things together, they'd add up to 0. So what we are going to do with this is we're going to turn this into a giant addition problem. And I'm going to add them down. 1 plus 5 is 6x. -2 plus 2 is 0y. And 19, oh sorry, my bad guys, this should be -1. Just a heads up. And 19 minus 1 is 18. So I'm left with 6x equals 18. Divide your 6. X equals 3. Now to get y, all you're going to do is plug into one of your original equations. Again, it doesn't make any difference which one. So let's go with the top one. So we have 3 minus 2y is 19. Subtract the 3. -2y equals 16. So y equals -8. And remember, your answers are always in an ordered pair. So my first goal was to say, okay, this right here were opposites, and I'm going to add them together. So what we're going to do is we're going to list out some steps in the process. So step 1, make sure that your system is aligned. Meaning x over the x's, y over y, and constants over constants. I'm going to abbreviate that because I'm running out of room. So standard form is essentially what you're looking for. This is a different way of saying standard form. So 3x plus y equals 10, and -4x plus 6y is 11. X's over x's, y's over y's, and constants over constants. So step 1, make sure your system is lined. Step 2 is going to be if opposites are there. So if when you're aligned that you see a clear opposite, -2 and +2, or -5 and -5, if opposites are there, add both equations together. If opposites are not there, multiply, and I will show you how to do this, multiply to make opposites. And then add. Step 4, solve equation for remaining variable. And then step 5, plug answer into original. All right, let's look at another example. Next slide. So if I'm giving you 3x minus 4y equals 10, and x plus 4y equals negative 2. So the first thing, check that they're aligned. I agree that they are. So next I want to see, where do I have opposites? Well, if you look in this column right here, my y's are opposite of each other, negative 4 and positive 4. So we can just go ahead and add these two equations together. 3 plus 1 is 4, so 4x. Those cancel out, and I'm left with 10 minus 2 is 8. Divide your 4. X equals 2. Now we can plug it into either equation. I'm going to plug it into the bottom one this time. So 2 plus 4y equals negative 2. Subtract your negative 2. 4y equals negative 4. So y is going to equal negative 1. So my answer is 2 comma negative 1. Now let's actually look at an example where I don't have opposites. Here we go. X plus 2y equals 11, and negative 3x plus y equals negative 5. Again, very much like substitution, it does not matter which variable you choose to focus on. So what I am going to do with you guys is we are going to look at the x's. We are going to say, I'm going to check these out. I can see right here that I've got a negative 3 in front of this x. And so the opposite of negative 3 is positive 3. So I'm going to take this whole top equation and multiply it by positive 3 so that it can be the exact opposite of the x below. So 3 times x is 3x to here. 3 times 2y would be 6y. And 3 times 11 is 33. Bring the bottom equation down. And now I've got my rows of opposites. So let's add these together. Those cancel out. 6 plus 1 is 7y. And 33 minus 5 is 28. Divide your 7. 28 divided by 7 is 4. So there's my y value. Now let's plug it back into either equation. You can actually plug it into any of these 4 equations. It doesn't matter which one. Let's go with this bottom one because the y is by itself-ish there. So 3x plus 4 equals negative 5. Subtract the 4. Negative 3x equals negative 9. Divide our lovely negative 3, and x equals 3. 3 comma 4. Let's look at one more example. One last example. 2x plus 5y equals 26. Negative 3x minus 4y equals negative 25. What I'm looking for here is I don't have any opposites that are present. 2 and negative 3 are not opposite. 5 and negative 4 are not opposite. Now, what a fast thing you can do is to flip-flop your coefficients. So here I'm going to eliminate the x's. So I'm going to multiply the top by 3 and the bottom by 2. That way they're both going to become 6. So I've got 6x plus 15y equals 26 times 3, which is 78. And then we'll do the bottom equation by 2. Negative 6x minus 8y equals negative 50. Now let's add these together. Those cancel. 15 minus 8 is 7. And that's negative 28. Divide the 7. And y equals negative 4. Positive 4. Sorry. 78 minus 50 is 28. Positive 4. My bad. You guys are used to me making mistakes in class, though, so we're not going to restart this slide. Alright, so now we're going to plug that into one of these equations. Let's do the top one. I'm actually going to go to the next screen because I am out. So I have got 2x plus 5y equals 26. So 2x plus 5 times 4 equals 26. 2x plus 20 is 26. So 2x equals 6. Subtract the 20. Divide by 2. And x is 3. So my answer is 3 comma 4. Alright, so let's wrap this up. Always look for opposites. We want things that are going to add to 0. So we want to eliminate a variable by adding them to equal 0.